Okay, I didn't ever want to make something like this, but this is comparable to the burning of the Library of Alexandria. Yeah, the one that set humanity back 1,000 years. Actually, wait a second. Let's see, Aristotle settled that the Earth was round in 350 BC, and it's almost 2019 now, so 2019 minus negative 350, wait, there's no zero here. Wow, 2,368 years is a big number. That's more than 2 Alexandria Library burnings. So yeah, we need to fix this now. With that being said, I present to you 4 reasons the flat earth is wrong. Wait, hold on. I accidentally capitalized flat earth in my script. Need to change that real quick. Can't let them think that they've become proper nouns just yet. Okay, back to the 4 reasons. Number 1, we've been to space. Number 2, lunar eclipses happen. If you've ever seen the flat earth model, you might notice that it doesn't allow for a lunar eclipse. Let me explain. A solar eclipse happens when the moon is in front of the sun and it blocks it out, which gives us a spectacular view. We're all good right there. Well, a lunar eclipse occurs when the moon is in a straight line behind the sun and the earth. When this happens, the earth casts a shadow on the moon. The shadow, by the way, is circular, further corroborating the globe earth. Anyways, I went to the Flat Earth Wiki, and though they attempt to explain a lot of naturally occurring phenomena, lunar and solar eclipses were suspiciously nowhere to be found. However, I did find this. This is apparently what the sun and the moon look like, and they specify that the lunar cycle is slightly slower than the solar cycle. So I'll spare them this time and allow for solar eclipses when the sun laps the moon. But the model still keeps the sun and the moon rotating above the earth, so there's no possible way the flat earth could cast a shadow on the moon. We even see lunar eclipses every few months, so it's not a super rare phenomenon. And for all I know, the moon is open to public viewing. Go debunk it for yourselves. And number 3, Antarctica is not a giant ice wall holding everything inside. When I showed you guys a flat earth model, you may have wondered what this white thing around the edge was. It's apparently Antarctica, and it's supposedly this ice wall that keeps water inside the earth from falling off. Normally, this is just an annoying thing that flat earthers throw into their model in hopes that it'll fix everything. But it doesn't, and it can easily be disproven because there's not a giant wall of ice, and there is no edge of the world. The only reason I brought it up was because very recently, on December 26th, Colin O'Brady completed an unassisted solo journey across Antarctica. He started out at the Ron ice shelf and made his journey to the South Pole. That's when he kept going and reached the Ross ice shelf. In other words, what happened here was he kept going south and eventually ended up going north, which is only possible on a globe Earth. Now, if you say that this feat is fake, you'd be disrespecting a lot of people, including Mr. O'Brady himself, who devoted a lot of time and effort to this, only to be falsely called out as fake. Now, on to my favorite reason. All maps are wrong. For a long time, humans have relied on maps, and as a side effect of living on a globe Earth, no map is 100% accurate. This is because no matter how much you stretch, squish, or tear the surface of a sphere, you can't get it to be flat. Therefore, you must distort the map to fit your needs. The Mercator projection, for example, stretches out the poles to keep everything at a 90-degree angle, similar to the grid lines formed on a sphere. This keeps all angles equal, so a 90-degree turn on a map is a 90-degree turn in real life. But like I said, there's always distortions. And you can see based on the grid lines that the poles are greatly stretched out. And in fact, though Greenland is much smaller than Africa, they appear to be about the same size. This is why we have tons of maps, each for a different purpose. The Mercator for navigating, Peters for area, conic projections for mid-latitude purposes, and many, many others. If the Earth was flat, all we'd have to do is draw it onto a sheet of paper, and it'd be 100% accurate with everything. But we still see complications on the flat Earth map. Like you see here, Australia is not wider than the US, and this map is all around more horizontally stretched out than it should be. It's kind of like when you do this. It just doesn't work. Well, that's all I have for this video. I'll probably be uploading more, and the next one will definitely be on another topic. I'll explore any other areas of my interest, but I did see some peculiar things on the official Flat Earth website. I'll check into those on another video.